Hey everybody, in this video we are going to talk about the volume of a pyramid. So what I have here is a pyramid and a prism. They have the same base and they have the same height. The prism is filled with water and we're going to see how their volumes compare. Okay, so I've got the prism filled with water. I'm going to see how many pyramids I can fill with the same base and height with the amount of water that is currently in the prism. Okay, so there's one. There's two. And there's three. It took three of the pyramid to hold the same amount of water as the prism with the same base and height. Now we're going to use that information to find the volume of some pyramids, but first I'm going to zoom in, and there it is zoomed in. So the volume of a pyramid is the same as a volume of its corresponding prism, but it's divided by 3 because the prism will hold 3 times what the pyramid will hold. So area of base times height divided by 3 will give you the volume of a pyramid. Area of base times height is the volume of a prism, divided by 3 is the corresponding pyramid. Okay, so capital B means area of the base, which means whatever shape the base is, we're going to have to use that area formula to find capital B. Then H is the height. Now the height goes from the base to the vertex, and it's going to be perpendicular to the base. So here I've got a triangular base, and the height goes from the vertex here down to the base, and it is perpendicular to the base. So what I have here is a triangular pyramid because the base is a triangle. And I've got tick marks on all 3 sides, which means we're looking at an equilateral triangle here. And I'm going to draw that base off to the side. Okay, so that is what the base of this pyramid looks like. Now in order to find the area of a triangle, we use half times base times height of the triangle. So the volume is half times the base of the triangle, which is 12, times the height of the triangle, which I don't know right now. So I'm going to draw in the height of the triangle, and that gives me right here a 6. So I can do 6 squared plus this other leg squared, so leg and leg, 6 squared plus, and I'll call it h for height, squared, equals the hypotenuse, 12 squared. So I'm going to do 6 squared minus 12 squared. 12 squared minus 6 squared. So I'm subtracting 6 squared from both sides. So I have h squared equals 12 squared minus 6 squared. And that is 108. Okay, then the square root of 108. Now I can simplify this. 1 plus 0 plus 8 is 9, and 3 goes into 9, so 3 is going to go into 108. So 108 divided by 3 is 36. I think I could also have put 9 in there, but that's okay, we're already started. So 36 is 6 times 6. And there's a pair, so I can stop there. So the height of that triangle is 6 times the square root of 3. Okay, then we'll multiply that by the height of the pyramid, which is from the base to the vertex, and that is 10, divided by 3. So I have 0.5 times 12 times 6 times 10. I'm going to leave the root 3 out of this. Divided by 3, and that is 120. So our exact volume is 120 times the square root of 3 inches cubed. Okay, our next pyramid has a square base. So the volume is the area of the square, which is side squared. So 8 squared is the area of the base, times the height, which is 10, divided by 3. So we have 8 squared times 10, and that's 640 over 3. I'm going to write that as a fraction. So I'm going to do 640 divided by 3, and then I'll use this right here, second function, and then I'll make a mixed number out of it, and I get 213 1/3, and that is in yards cubed. Next, I have another triangular base. Now this time it's a right triangle. So this is what the base looks like. Now 12 and 13 are perpendicular to each other, so I can use those as the base and height of the triangle. So the volume is half times base times height of the triangular base, so 12 times 13. This is the area of the base, half times 12 times 13. Times the height of the pyramid from the base to the vertex is 15, divided by 3. So we have half times 12 times 13 times 15, divided by 3 is 390. So the volume is 390 feet cubed. Okay, next we have another square base. So the area of the base is 50 squared. The height from the base to the vertex is 45. Area of base times height divided by 3, 50 squared, times 45, divided by 3 is 37,500. So the volume is 37,500 meters cubed. Our next pyramid has a base that is an octagon. So we've got an octagonal pyramid. The octagon is a regular octagon, and for a regular polygon, the area is 1/2 times the apothem times the perimeter. Okay, so to get the apothem, that would be this right here. I'm going to have to first draw in a radius and find this half central angle measure. To get the half central angle, we do 360 divided by the number of sides. That will get me a central angle, so 360 divided by 8 gives me a central angle of 45 degrees, but I want half of that, 22.5. So I take that central angle and divide by 2. So I get right here 22.5 degrees. Now I know that a side length is 4, which means this right here, a half side length, is 2. And what I want is this apothem right here. Okay, so I'm going to use sine, cosine, or tangent. So what I have is the opposite leg and the adjacent leg. I do not have the hypotenuse. So in SOHCAHTOA, I'm looking for something that has opposite leg and adjacent leg, but not hypotenuse, and it is TOA. So I'm going to use tangent. So tangent, 22.5 degrees, is to 1, as the opposite leg. 2 is to the adjacent leg, A. Okay, now the fastest way to solve this is to switch these, which we can always do in a proportion, and divide. So we get A over 1, which is A, equals 2 over tangent 22.5 degrees. So we have 2 divided by tangent 22.5, and that is 4.83. Okay, so the tangent, or the apothem, is 4.83. So for the volume of this pyramid, I have the area of the base, half times the apothem, 4.83, times the perimeter of the base. Now the base has 8 sides, and each side is 4. 8 times 4 is the perimeter of the base, and that is 32. Okay, so for perimeter, we do 8 times 4, and that is 32. So I put 32 in for the perimeter. So there is the area of the base, half times apothem times perimeter. Now times the height, which is 15, and divide by 3. Okay, so now I'm not going to try to write an exact answer for this one because I've already rounded this, so whatever decimal I get, I'm just going to keep it as that decimal. 0.5 times 4.83 times 32, that's half times apothem times perimeter, times the height of 15, divided by 3 is 386.4. So the volume is 386.4 inches cubed. And our last pyramid gives us the volume, and we're looking for the height. So the volume, 1152, is equal to the area of the base. Now this base is a right triangle with 18 and 24 as the legs. And in a right triangle, those legs are perpendicular, so they will be the base and height of the triangle. So for the triangle, we do half times base times height, then times the height of the pyramid, which is x, divided by 3. Okay, so I'm going to multiply both sides by 3 to cancel this out. So 1152 times 3 is 3,456 equals, now I can simplify by multiplying 0.5 times 18 times 24, and that's 216, so equals 216x, and then I can divide by 216. So 3,456 divided by 216 is 16. So that is 16 millimeters for the height.